Okay, so since I'm not going to be here to walk you through how to do this particular lab or this particular worksheet, I wanted to make a really quick video to walk you through how to do the diffusion and osmosis examples for Unit 6 practice worksheet number 1. So if you're looking at the worksheet, you would notice that there are some directions. The directions themselves um, include below are some animal cells that are beakers of various concentrations. It is your test to determine what will happen over time, but first some definitions. So the first definition that we need to discuss is solute versus solvent. The solute is the substance that is getting dissolved. Think about like you put salt in water, salt will be the solute. The solvent is the substance that does the dissolving. You put salt in water, water will be the solvent. So solute gets dissolved, and solvent does the dissolving. Now for this worksheet, there are 4 basic things that you're going to have to do for each of the, I think, 18 problems. You're going to first start by drawing a red arrow to show which way the solutes, the things that are being dissolved, would move by diffusion, and a blue arrow to show the direction in which way the solvents, water, would move by osmosis. The third thing you'd have to do is you would label if the cell is going to shrivel or swell as a result of the movement of water or the movement of the solute, and then you're going to identify the type of solution which is in the cell, which is hypertonic, isotonic, or hypotonic. So here we have the very first example. So if you're looking at your worksheet, there would be this particular example right here. And so we're going to talk about how this works. So this oval right here is your cell, and the rest of the beaker is the water or the solute. Okay. So now in this, or the solvent. Okay. So now inside the cell, you will see that there is 90 and 10%. So 90 plus 10 adds up to 100. So the concentration of the solute and the solvent inside the cell has to add up to 100. The concentration of the solute and the solvent outside the cell also has to add up to 100. So 85 plus 15 gives you 100. Now, in this instance, I'm going to look firstly at the solute, okay? And what I'm noticing is that my 15% solute right here, this amount is in greater concentration outside the cell than inside the cell. So the 10% solute is lower in concentration than the 15% solute. So I'm going to take my red arrow and draw an arrow pointing into the cell. The next thing that I'm going to do is I'm going to look at the water. So my water here is 90% water inside the cell and 85% water outside the cell. Inside the cell is greater concentration than outside the cell. So we have to draw our arrow so that it's going to, so we have to draw our arrow so that's showing that water is going to leave the cell and it's going to go into greater concentration, it's going to equalize outside the cell. So water leaves the cell in this case, and solute is entering the cell. Now the next thing we have to decide is, I guess, which is happening here. Is this hypotonic, hypertonic, or isotonic? And you have to remember from the notes that in a hypertonic solution, it's going to shrink, and in a hypotonic solution, it is going to get bigger or burst, right? So in this instance here, this is a hypertonic solution, okay? And I'm going to bring this over here, and that means that this cell is going to shrivel, okay? So in this instance, what happened is that as the solute entered into the cell and as the water left the cell, so the water is leaving the cell, and when the water leaves the cell is going to get smaller and shrivel up, and we call that a hypertonic solution. Okay, so that's your first example that you have to kind of work your way through. The second example that you have to work your way through, so this is going to be number 11 on the back side of this worksheet. Oops, that's not what I wanted to look at. So here's the back side of my worksheet. This is number 11. I just grabbed one off the back side. Now, note that there's some blanks here that we have to address. So the first blank the first thing we want to do is we want to make sure that inside the cell adds up to 100%. So if inside that cell needs to add up to 100%, what plus 40 is going to equal to 100? Well, that's going to be 60. So that means that I'm going to need to put 60 right here, okay? Right here, okay? So 60% water inside the cell, 40% solute inside the cell. Down here, this also has to add up to 100. So in this case, I need to add, get it to add up to 100, and so what plus 30 is going to equal 100? Well, the answer is 70, so I'm going to go ahead and grab that and put that right about here, okay? So now I've got my concentrations correct. So the next thing that I'm going to do is I'm going to try to identify what's going to happen. So this time I'll start with water. Inside the cell is 60% and outside the cell is 70%, and so in that case, the value of the amount of my water is going to travel inside the cell because it's a lower concentration. So inside the cell, lower concentration. I've got to bring it to the front. Okay. Order. So inside the cell, increase in concentration. Inside the cell here, I have 40% solute, and outside the cell, I have 30% solute. So in this case, we're going to need to identify that the solute is going to leave the cell. So this time I'm going to have solute exiting the cell, which, if I do this correctly, I got to bring that to the front, and here. Okay. All right. So that's going to leave. Okay. So now in this case, what's going to happen is that because water is entering the cell is going to get bigger and it's going to swell up. And when the cell gets bigger and swells up, we call that hypotonic. This to the front, order, bring it front, swell, bring that to the order, bring it to the front. Okay. So it's going to swell, and this one is going to be hypotonic. Okay, so those are the things that you kind of need to think about when we're talking about this particular activity. So you're going to be making sure that these are always doing what they're supposed to be doing by tracking the movement of water into and out or out of the cell, and tracking the movement of solute into and out of the cell, and then identifying if it's going to be hypotonic, isotonic, hypertonic, and then identifying if the cell is going to swell or shrivel. And that's how this worksheet works. And if you have any questions, or do the best that you can. If you have any questions, we'll talk about them when I see you next.